All right. Thank you everybody for coming. So today will be a continuation from yesterday about the. Oh, it's very loud. Let me just check my microphone. Just give me one moment. Okay. You know what? Let me put my microphone away a little bit. Okay, just in case. All right. Good. Yeah. If that's too loud, okay, it's fine. Okay. Okay. Good. Very good. Okay. So today I got 3 more questions from. No problem. I just got 3 more questions from Google Doc, and then I want to talk about them. If you got any follow-up questions, please let me know. Okay, let's go one by one. They're pretty straightforward, but since your fellow student asked, I think I want to address them properly. Question number 1. I think your fellow students was basically maybe a little bit confused about why we will get a runtime violation when we try to do the cast. Okay, I want to explain that quickly. Okay. Basically, if you look at this example that we did in the class in lecture 8, the part 1. So basically, you want to see we got a phone number over here, and also we got also the birthday, right? You can see these two variables are different types, string versus dates. Okay. However, okay, let me just show you one thing. I didn't include the code over here, but if you recall the definition for a general book over here, just show you very quickly. Remember the definition for the general book because it's simply an array of any. So that means whenever you add, you can add anything. And also when you return something, you can also return anything, right? As far as the compiler is concerned. Okay, just to remind you. Okay, having that in mind, let me now go on with this illustration over here. Basically, we created a book instance over here. And then specifically, we talk about 2 additions. You can see line number 5 and line number 7, right? Line number 5, we say Suyang with the phone number, which is a string. And also in line number 7, we say add Yuna with birthday, which is over here, birthday, which is of type dates. Basically, there's something I didn't quite draw in the lecture, but I can draw that again. So you can think about what we're having is the records array. Basically, it's going to be of size 2. Okay, index 1, index 2. As far as the compiler is concerned, the static type for each one of them is simply just any, right? That one has no question about it. And now let's think about how things are going to happen. Line number 5, we're inserting the first element over here, this first record, basically, right? So we only talk about records, not the name. So that'll be phone number. So you can think about this one over here is actually phone number. And that one is basically a string. Okay, I'll just say it's a string. And just remember that one is associated with Suyang. You can think about the names array, just another separate array. I just wouldn't draw it, just to keep it clean. And then we have in the second one, line number 7, we are basically saying Yuna has the associated birthday. So you can think about it as polymorphic because index 2, it is pointing to birthday, which is of type dates over here. And just don't forget, this is associated with Yuna. All right. In your lecture, I talk about basically 2 casts. I was saying that, let's say I want to retrieve each one of them. For example, if I simply say, let's say, if I say the book, which is B, if I say b.get, and then I simply put for example, Suyang. Okay, so now what you need to know is this one over here statically. The static type is simply just any, and the dynamic type would be string. Okay, similarly, if I try b.get, also Yuna over here, statically, okay, so for this line over here, this expression, you can see we're basically calling the same get routine, the same query, but statically it will still return the any type, right? And the dynamic type is going to be the dates. Okay. Let's just make sure that's clear to everybody. Okay, if you got any questions, please interrupt me. Otherwise, I'll assume you're actually okay with so far, right? So you will actually see this kind of a polymorphic array or polymorphic collection, not just in the inheritance review section. The reason I put that topic there for the review is because for all the remaining design patterns that we will talk about, you already saw a polymorphic collection in the states pattern. And then for your coming lecture for observer and also event-driven design, you will also see polymorphic collection. And then later on for the composite pattern, visitor pattern, you'll also see polymorphic collection. So it's really important for you to know how you can visualize them, okay, and how to check their property. Okay, your fellow student question was specifically about this particular cast. So let's say this. When we say we want to cast B dot get Suyang, okay. So let me just use the right color. Okay, so it should be green. So when we say B dot get Suyang, so you can see this one over here is going to return dynamically a string, basically this type over here, right? And now what we are trying to do is we're trying to cast that into a dates, right? And now that shouldn't be possible because think about this. So this should be this expression over here, this expression over here. Okay, let me just write it down. So this expression over here is going to be false because dynamically it's actually b.getSuyang, as we agreed previously, is going to return a string because the dynamic type string cannot fulfill the expectations of the cast type, which is the dates. Okay, so why can it not actually fulfill the expectation? If you look at the inheritance hierarchy, you can see over here, this is the string type. So this is the string, and this is the dates, right? Think about this one over here is the dynamic type that we're talking about, and this one over here is actually the cast type. And apparently, from the inheritance hierarchy's point of view, they have only one common ancestor, which is the any class. You can think about any two classes in Eiffel, they have the same common ancestor at least for the any. And also, every two classes in Java, they have the common ancestor objects. That's always the case. So if that's the case, so that means these two classes have nothing to do with each other. So for sure, when you are expecting dates, you definitely cannot substitute it by string. Okay, so this is why you're going to get false over here. Consequently, you're going to get the runtime violation. All right, guys, I hope the first one is okay for you. I think I'm just clarifying for your fellow students. They were just wondering about why we would get the runtime violation. So I think the critical thing for you to really answer this question over here, not just for the quiz, but later on for any judgment you have to make. In that case, you have to really trace about how the polymorphic array has been built, and then specifically what's the dynamic type for each one of them. I think that'll be important. Once you get it straight, maybe to visualize it. So I think answering a question like this will be quite easy, right? Straightforward. All right. Okay, that's the first one. And the second one is not so related to the pattern or generics themselves, but just a relevant question to the course. It's about using multiple constructors for your class. That could be useful for your project, so I can mention that quickly. So as I said before, in Java, right, let me just remind you very quickly. So about constructor. So in Java, constructor names must match class names. Okay, number one. And number two, overloading is allowed. Okay, so I hope you know about what overloading really means. Overloading means, for example, if I have class A, for example, right? If I have class A, like that, and now I can say A over here simply takes no parameter, right? So this will be one constructor, and whatever definition here. Or I can say A over here, I can say that will take integer, maybe I. So that'll be one more constructor, and so on. As long as the parameter list can distinguish between constructor from constructor to constructor, in that case, it's allowed, right? So overloading simply means you have the same method name, but they have different parameters. Okay, so overloading is allowed. So that's about the case for Java. Okay, so now to illustrate the difference in Eiffel, you can think about 1 and 2. Okay, so now what about for Eiffel? Now for Eiffel, okay, now for Eiffel, the must part is not true anymore. You don't really need to have the same name as a class. Usually it can be called make, it can be called create new, or whatever name, okay, arbitrary name, okay? And also for Eiffel, overloading is not the case anymore, which means when you want to create multiple constructors, they must have different names. So if you really want to compare these two languages, that's how you can think of, right? Let me give you an example, especially for the Eiffel part, okay? Let's see this. Let's say we have a class over here. Let's call it person, okay? And then before I declare the constructor, let me just put the create over here, meaning that I'm expecting to put kind of like a list over here. I'll put it in just a moment, okay? It's going to be a list of commands which are going to be used, which are intended to be used as constructors. Okay, let's now talk about just commands, okay? Let me just omit about the attributes. You can assume we got the various attributes like a name, maybe weights, heights, age, and etc. Okay. Let's say feature over here. Let me just say commands. Let me just give you two constructors, for example. So over here you can say make with name. Okay, in this case, we have the new name over here. That's simply a type string. I'll say str, just for short. Okay, so this is a command. Again, you can put any conceivable implementation over here. Also, I'm going to omit it, right, just to simplify our discussion. Let me put another one here. Let's say we got, let's say make with age. And then I can say maybe some integer age, integer. Okay, apparently you can see I'm not really violating the fact that I cannot have overloading, because you can see they simply have different names. So I would say typically when you choose the names for commands, for queries, or for attributes, or for constructor, you should really have different names. That's the principle you have to follow for this particular language. And then you'll be do and also end. All right. So that's about the two commands we have. Okay. So that's about this class over here, right? Okay. So this part over here is the Eiffel class that we're going to illustrate. And I'll write the client code for you as well. Sorry, let me do it again. Okay, it's not very promising. Okay, let me forget about it. Okay, for now. All right, so now that's how about we declare the constructor? Okay, let me erase this part here. So now I want to really, for both of them. So one is the make with name. The other one is make with age. So what I would do is I'm going to say creates. I'll say make with name, and also comma, make with age. Okay, so from the supplier side, that's how I can declare multiple constructors. You can have as many constructors as you wish. Let's say, for example, for your projects, right? So it could be that, well, of course, this can be applied to many scenarios. Let me just make some example. I'm making that up. For example, you may have a class called game. In that case, you may have a default constructor make, which does not take any parameter, in which case you simply create an empty board, or maybe a board with the default dimension. You can have another constructor to say make with dimensions, in which case that will take maybe two parameters, the row and the column size, right? So it's kind of up to you how many parameters, if any, you want to put for your constructor commands, okay? Let's see how we can use this. Your fellow student also got a very specific question about how you can use it, okay? Let's say we declare, let's say P over here. So green means the clients, okay? Let's P of type person. Okay, so now if I say creates, let's say P dot, so I don't really have the curly brackets over here to say person, because I just want the dynamic type to be just the same as the static type, right? That's something we emphasize many times. So now if I say P dot, maybe I want to use the first one to say make with name, make with name. Maybe I would say maybe Una over here. All right, and then that's the first one, and then I can have another one. That's so after this, basically I'm having maybe P pointing to a person object over here. Okay, and the person object may have many attributes, but one of them is simply just the name. Okay, just one of the attributes. So this constructor may just initialize just the name. The name is just going to be a string for unit. Okay, so that's the first one. All right. So now let's try this. What if I also use just P again? Let's say if I simply say create over here, I'm using the same variable over here, right? Actually, I believe this was also mentioned in your Lab 0 tutorial video. Maybe your fellow student forgot about it. But let's just emphasize again. If I say p.make, let's say with, let me use another constructor over here. Let's say make with h. Okay, and then maybe I would say maybe 6. All right. So now what's going to happen here? First of all, you can see that we are really using the create keywords over here. So that means we are really creating a new objects. It's just that we are storing the address of the new objects in this same variable, meaning that P is not going to point to this particular object anymore. Instead, it's going to point to just another new object over here as of type person. And then in this case, we're only initializing the age. Maybe for the name, it's simply just not there, just for now. Okay, well maybe there's some default value in the constructor, but this can up to your implementation. So one of the attributes over here is simply just age. I'll put 6 over here, and the rest of the attributes. Okay, okay. So that's to clarify to your fellow students. Number one, you can have more than one constructors. You can choose multiple commands as the constructors in your class. Okay, that's number one. Number two, you have to be careful that overloading is not supported in the Eiffel language. For example, what would not compile is like this. For example, if I want to say, I simply, let me just use orange, right? Let's say hypothetically. If I simply get rid of the, rename this to just to be make, and then I rename this just to be make, for example, and then I want to get rid of these two, and then I simply say, it's simply just a make. This might be conceptually what you were attempting to do, because that's more or less more consistent with how you understood about how the Java constructor work. However, in this case, it's not going to compile in the case of the Eiffel, because number one, you can see we don't really support a method overloading. So having the same routine over here, but with simply different parameters, is simply not allowed. Eiffel compiler will only check to see what are the names for your routines. If you got duplicates, doesn't matter if you have different parameter lists, doesn't matter. It will just not compile, all right? So if you simply list the make over here, it's simply not going to compile, right? That's point number two, okay? Having known that, okay, let me just undo, right? So I can keep the original working version here for you, all right? But in case you want to review this part, you can just go to a timestamp and then rewatch that part, just a few seconds. All right, and then another thing I want to mention is, when you are trying to use a constructor, again, every time if you believe you want to create a new object, you have to use the create keyword, right? That's why the second use of the create keywords on the same variable is simply just going to redirect that object into a new that variable into a new object. All right. Okay, so that's about question number 2, just about whether you can use multiple constructors. I think this might be a little bit more practical question, maybe for your developments. All right. Any follow-up question to this about multiple constructors? Okay, since everybody's okay, right? I'm also monitoring the chat window there. All right. Okay, so third question here from Amir is about a state design pattern. So let me read out the questions. Let's read it out first together. Basically, in the state descent pattern, we assume all the states, for example, initial, flight, inquiry, etc. Remember, we got the state class under which we actually got different effective state classes, right? You can think about this is the states, which is deferred, under which we got initial, we got flight, inquiry, and also confirmation, and etc. Right? I didn't read it out. Okay, let me just remind you. This is the hierarchy. For the inheritance, right? You got states under which you got initial, help, final, etc. Mia's question is really about the read, display, correct, process, and message. So these are so-called sub-steps. Remember, these deferred routines are so-called components of the pattern, right? And the execute over here, which is effective, is about the pattern itself. Okay, let's go back to the question. Okay, so the question is, all the states over here, let's say they all have sub-steps, display, read, message, process, etc. What if the different steps have different sub-steps? Okay, I believe what Amir is trying to say is this. Okay, let me just try to understand if I'm trying to paraphrase to see if I'm understanding correctly. Let's say, just for example, let's say in the state class, right? The state class, we define the execute, right? And then you can think about conceptually the execute contain many steps over here, right? Execute is really the template. And then it might refer to the read, it might refer to correct, and also it might refer to display in whatever order, right? I'm just trying to list the component. I'll just list one more. And also, I believe message, right? So these things over here are the steps or components of the template. And the execute over here, right? Just don't forget, this part here, as we mentioned, is the template, right? So these are kind of the decoration for the state class, the top of the hierarchy, right? So let's say this. Let's just say, for example, let's say we talk about the two descendant classes. Let's say we talk about state inquiry and confirmation, okay? So let's say somehow there are two classes that inherits from these two. Sorry, let me just put it this way. Let's say there are two classes inherited from the states. So one is the seat inquiry, okay, this class over here, and also we got confirmation, which is over here, right? Yeah, typically when you draw a design diagram, try your best. Whenever you're trying to draw inheritance arrow, try to make them vertical like this. Okay, not like this, and also not like this, like a horizontal. Here I have no choice really, but for you, you got more space on your diagram. Also got more time to play with your diagram structure. But typically, when we talk about inheritance, it should be vertical and then should be from bottom to bottom up, right? From the child to the parents. Anyway, that's just an aside. So now over here, let's say this. When we got, let's say, seat inquiry over here, let's say for this particular subclass, execute is supposed to be inherited verbatim. And now, let's say for each of the steps over here, right? We're going to redefine, we're going to implement, not redefine, just implements. We're going to implement, for example, read and also correct. And for simplicity, let me just say two of them, but you can imagine that you should really implement all the defer routines that correspond to the components for the pattern, for the template, okay? And similarly, let's say we talk about another child class, which is a confirmation, right? And for, let me use a different color, maybe. Let me use green. Okay, so for confirmation here, so now for confirmation, we should also define different version for the read and also correct. All right. So what Amir was really asking was, he's okay with the steps, but what about different steps have different sub-steps, okay? My immediate response is, you're basically talking about maybe the step read over here has some sub-steps over here, which are different from the sub-steps for read. I think that's okay. We're still falling within the state design pattern. For example, you can see the read over here might simply contain maybe sub-step number 1, number 2, number 3 over here. And for the read over here, it might just contain different sub-steps, maybe 4, maybe 5, and 6 conceptually, right? That's okay, because in the state design pattern, you're supposed to implement the read in each state independent of other states for the component. So that's okay. Yeah, that's not an issue over here, okay? So Amir, does it make sense over here? For example, what if seat inquiry needs to do one extra activity for window, no window extra options? Are you trying to say the execute might be defined differently? You're not really saying the, oh, you want to, I think what you really meant to say is this. I think for the sub-step, we are actually okay over here, right? Let's say we have another, let's say, let me just choose a better class over here. Okay, let's say which one I can choose. How about reservation, okay? Let's say I have the reservation class over here. And then let's say we still have to implement the read, correct, display, and message. Let's say all of these we have to implement, right? Okay, all of these will be implemented. Okay, the read, for example, and also correct, and etc. Let's say if you got some additional sub-step, right? In that case, for example, you can say maybe, for example, choose the seat. For example, let's say you have an additional step over here. So I think in this case, what you will do is you're going to modify possibly the execute template over here. I would say that may not be so common for the state pattern, but if you really want to do it, you can feel free. How would you do it? For example, you might simply say you're going to redefine the executes in the context of the reservation. Okay, so how do you really redefine? We talked about it yesterday. You can definitely, first of all, you may want to reuse, if applicable, you may want to reuse maybe everything that's actually from the execute, maybe. I don't know. Maybe you want to reuse it, maybe you don't want to reuse it. You can say precursor if you want to reuse it, and after that, you can also use the choose seat. And notice that the choose seat is only available at this level over here for the reservation. Okay, I think that's how you can do it. Okay, good, no problem. But I would say if you decide to do state design pattern, I would say the bottom line, it may be unavoidable that you may want to redefine the pattern maybe in one of the subclasses anyway, but I would say try to put as much code as possible into the common pattern over here so you can maximize the reusability of your code. I think that'll be the lesson you want to take, all right? Yeah. All right, so that's about all the 3 questions I can see from the Google Doc. Okay, let me have a check to see if there's any new questions there. All right, let me take a look. Let me refresh the browser. Yeah, I believe so far, okay, everything has been answered. Yeah. Okay, so the Google Doc has been answered completely, all right? And then, so now I want to see if you got any more questions related to the lecture, okay? Feel free to ask me any question before the before this week. Is it Robbie?
Yes, hello.
Hi, Robbie. Hi, questions.
I don't understand what the point of read is in ETF.
The point for, so can you say that again? Which part of the ETF?
Like a photo read. And that's the design pattern.
In the design pattern. Which design pattern? You mean the state design pattern?
Yeah.
Yeah. Okay, Robbie, you can help me understand. Are you referring to this diagram over here?
Yes, the read.
The read?
Yeah.
Oh, the read, I see. Okay, sure. So Robbie's question is about the read let me just go back to that particular slide. Yeah, so Robbie, let me just confirm. You're talking about the read over here, right?
Yes, in the ETF, how would you use it?
Oh, in the ETF, how would you use it? Okay, so think about these are just examples, right? So I think the important thing is execute over here. Okay, I might know what you're basically thinking about how you would apply this to maybe your projects, right? So let's say this. First of all, execute over here is simply just a common pattern, right? It's a common pattern of code that can be reused by all the state descendant classes, number 1, right? It's a common pattern, right? To be reused when in the context of inheritance. Okay, so you can think about overall it's simply some control structure, right? So you have some loop maybe, and also you may also have some if conditional, right? And then you can and then the important thing is every routine you're mentioning here, display, read, message, good, process, and correct. All of these are really referring to, for example, display is really referring to the display over here, which is simply deferred. What that means is at the runtime, when you try to say a particular state.execute, for example, if I say s.execute over here, depending on what the dynamic type is for the s, in that case, that will be seek inquiry. So that means when you execute this, when you say s.execute, at some point it is going to reach this particular part for the execution. When you reach over there, it will be as if you call s.display. And then when you call s.display, which version of the display is it going to call, right? Apparently, you can see at the state level, over here, at the state level, the display is simply just defer. So it's not possible we are calling that version. It's not possible. So instead, we're going to go to the seek inquiry, which is dynamic type. And then we're going to the display over here in that level, right? That's about dynamic binding. I think that's the main message you want to take from there. So if you ask specifically about the read over here, so the read in this particular example over here is simply just about reading inputs from the user. So for this one, you may or may not actually have the direct correspondence to your project for the Space Defender 2 projects. You may not. But if you do actually want to apply the state descent pattern in your projects, you should really think about, is it possible for the different states in my projects? For every state, there is a common pattern of execution, in which case I can simply define the pattern structure in the state class. And then individually, I can refer to different components as the defer feature that's defined in the state class. And then in the descending classes for the states, I can actually implement each one of them to make them effective. So I think that's a main lesson for you to learn. So Robbie, is that okay?
Okay, thank
Yeah.
you.
So I would say don't worry too much about just this read specifically, because when, for your project, you're dealing with basically like a Space Defender game. But in the lecture, we are talking about reserving your flights, right? It's like a two different design problems we are solving. But there might be some common part you want to use a state descent pattern, but the read specifically may or may not be applicable. Okay, that'll be my response. Right. Okay. Guys, any more questions about the lecture? I can pause a few moments to see how you're doing. All right, let's see if we got any. Amro, you okay? Good. Oh, Amir, you okay? Good. Good to know. Amro and Amir. Okay, good. I see some new name over here. So Judy, are you okay? Very good. Okay. Okay. Yes, Manor. So could I explain the part of the precursor use again? Yeah, sure. So are you talking about the precursor over here specifically? Is that what you're talking about? Okay, good. Okay, let me make it a little bit concentrated discussion. Okay, sure. I think what I meant to say over there, let me try to make it very clear. So that could be useful for you if you want to apply it, right? Okay, so think about this is the top level of the hierarchy, right? So this is one class for the state class. Okay, so this, and then let me talk about maybe two subclasses, right? For example, let's say we got reservation and seat inquiry, okay? So let's say we got two classes over here. Number one, we got seat inquiry. One moment. Okay, so this is one class. Okay, so this is effective. And notice that the state class is deferred. Okay, and then let me make this a little bit down over here. Okay, and then we got another one. So that's the reservation, let's say. That should be also effective. And the inheritance relation is, we actually got this one inherits from here. And also, this also inherits from there. Okay, so now just get these two classes, for example. So the precursor that I was talking about is like this. Again, let me just mention what you know already. So the execute over here is basically the template. Typically, if you want to adopt the state design pattern, the template that you define in the state class over here should really be a common pattern that can be shared or can be reused verbatim for most of the state classes. However, there might be some exceptions, right? Which makes it may not be so much faithful to the standard. So that's okay. So let's say this. Let's say for the C inquiry, we are just going to reuse the execute verbatim. So that's why over here, we don't say anything about the execute. On the other hand, it will just be reused. On the other hand, let's say over here for the reservation, let's see if I can move that maybe a little bit too, so I can make more space for myself. Okay, over here. Let's say for the reservation, we are actually going to redefine the execute. We're going to redefine that, right? So let me write some code over here. Basically, there are two options for you whenever you want to redefine a routine inherited from your parent class, right? Either you can simply just do something that's completely different. And for example, one suggestion Amir suggested was, we can say maybe you want to choose whether you want to sit in the aisle or sit by the window, right? So here, it could be that you just completely redefine the pattern, and then somehow you also say choose window, right? And choose window is actually a very unique feature you only introduce at this level over here. So this will be considered as acceptable, right? Even though it's not a standard, but it's fine, okay? You can think about this feature over here is only unique to reservation class, okay? So this will be approach number one, okay? I'll say one over here. What about approach number two? Approach number two is maybe I simply just want to say I want to reuse basically this part of the pattern verbatim. However, I just want to add something to it. In some way, I'm trying to extend the pattern in the case of a reservation. In that case, I can say for the execute, alternative number two, you can say execute redefine. And then when you try to implement it, so now you can use the precursor keyword. So if I simply say precursor over here, so as we learned from the previous lecture, so precursor is like a super in Java. So precursor over here is saying that as a first step for the execute in the context of the reservation, I'm going to call this particular execute over here that's inherited to me from my parent class. Okay, so this is about a precursor. And then after that, I can do anything additional as I judge necessary. Right? And then after this, I can do whatever I like over here. That's kind of extending the pattern that I inherited from the parent class states. And then over here, maybe part of it is I want to say choose window. So now you got two alternatives over here for you. Either, actually you got three. So think about alternative number one. In the C inquiry class over here, you simply just don't really redefine the execute. So let me just say this, put another one here. So alternative number 0, execute reused completely. Meaning that we don't have to redeclare the execute in the context of this particular class, right? So that's alternative number 1, okay? Number 1, and for number 2, you might say you want to redefine the execute over here by simply just redefining completely about the control structure over here. And you might just also refer to some routine which you only declare at this level, okay? Alternative number 3, you can also try to say, I want to reuse the inherited pattern by calling the precursor, which is going to reuse this part of the code. And then in addition to it, I want to do something more, right? So that's basically the 3 alternatives you have. So Manor, is it okay? Very good. Okay, good. Yeah, I would say whether you want to use this guy here, which is more standard, or you want to use either of these two, slightly off the standard, but that's definitely fine if you find the need. Yeah, very good. So let's see, anybody else? So Leo, are you okay? You're good. All right. How about Nina? Are you good? Good. How about Chi? Are you good? Oh, you just joined in. Okay, sure. Yeah. How about Si Wei? You okay? All right. Okay, good. Yeah, guys, I mean, the Q&A is really dedicated for you. I mean, just any question. If you don't have questions, I'll be equally happy too, right? I can pause for a few moments just to see. Yeah, take your time. If you're thinking this way, I think since for the rest of this course, we don't have that many weeks left. I would say maybe except for the last 1 or 2 weeks, in which case we're going to talk something called the software verification. In that case, we have to link a little bit more to the 1090 stuff you learned. We want to link between formal logic together with software design about verification. For that part, maybe you will have more questions. But I think after the reading week, we're mainly just talking about something you knew already about inheritance as a review, and also about design patterns. I would say for each design pattern there, it's really just about code structure. So I don't think it's really that challenging for you. So maybe that's why you have less questions. But before the reading week, we actually covered quite many challenging stuff, especially about the contracts. So maybe that's why you guys were a little bit more active on the Google Doc. All right. Jiahao, you okay? Good. All right. How about Vin? You okay? Very good. Very good. How about Hatching? Good. Okay, that's good. That's good. How about Bo Tao? Are you okay? Very good. All right. Okay, maybe I'll wait for. Okay, let's see. We got from Hashim. Okay. Yeah, Bo Tao, give me 1 moment. Let me answer Hashim first. Yeah, you can definitely ask me 2 weeks ago. That's fine. Let me answer Hashim first. Is static variable supported in Eiffel? I would say it's supported in a way. Static variable. I don't think there's anything called like an equivalent to static variable in Eiffel. However, we do have static. Well, what you learned in Java about static methods. I think we have something very similar in Eiffel. So basically, that's also something covered in the Lab 0 tutorial. I can mention that quickly, right? You're basically asking about static methods, right? Of course, in Eiffel, we call it routine, but similar stuff, right? Just different terminology, okay? How would you do in Eiffel? Basically, you will still declare your normal routine, right? Your routine over here, you might have some parameters over here, and then you may have some return type, okay? Doesn't matter, or maybe simply a command. And then you have some implementation over here. This is just normal. And in order to actually make a particular routine, static, right? Meaning that it belongs to the class rather than belonging to specific object instances, right? In that case, you have to put a special post condition. Does anybody remember from Lab 0? What should we put as a post condition over here in order to make it static? Anybody remember? I just need to put something over here to make it static. But if does anybody remember what I should put over here? That might be something you wanted to do, maybe for project, you just forgot, right? Yeah, Jiahao, that's very good. Exactly. Yeah, you would just need to say class over here. You can think about this predicate. Class is treated as a predicate that simply just returns true all the time. But what that signal to the compiler is that whenever you have a routine which contains one of the post condition as class, so that means this particular routine belongs to the class that's enclosing it. Okay. So yeah, so that one is about static routine. Yeah, and how exactly you can use it, you can refer to left 0. So Hashim, is that okay for you? Very good. Yeah, you can. If you have trouble finding the use of the static routine over here, let me know. I can refer you to which class you can look at. Just let me know. Okay. So now, Botao, yes, question. You can feel free to speak up if you wish. Otherwise, you can type. What's your question from 2 weeks ago? I suppose you're typing. Okay, let's wait. So both of you are typing, right? I hope.
Sorry, Jackie.
Yes, I'm typing, but
yeah,
can you hear me?
Don't worry, I just want to make sure. Yeah. So Robbie, I'll get to you maybe after Botao. I'll get to you, Robbie. Yeah. Bear with us.
Excuse me, Professor, can you hear me?
I can hear you, but your sound is a little bit distorted, but that's okay. Yeah, what's your question? Go ahead.
Okay, so my question is about the expanded class. My question is confused around in Lab 3 and how we try to ensure that the shell is it always is the same name. I mean, how
Botao, actually, it's difficult for me to hear you correctly. Actually, your sound is a little bit, it's not very clear to me. How about you type on the chat window?
Okay.
Yeah, please. Thank you. Yeah. So Botao, while you're typing, let me just take a. Okay, let me take a look. Let me while you're typing, let me answer Robbie. Robbie, what's your question? Go ahead.
What is the class keyword? The difference between the class keyword and expanded?
The keyword expanded.
Yeah, what is it? That's a class keyword.
Oh, you mean the class keyword over here? Yeah. You mean what that means?
Yeah.
Okay. So Robbie, so this class keyword over here, we talk about it in lab 0. Let me okay. So the class keyword over here, you can think about when you use a class keyword in the context of the post condition. Okay. Number one, always evaluate to true, which means it's as if you didn't put any post condition there. It doesn't really make any special meaning, right? It's just some indicator to the compiler. Okay. First of all, always evaluates to true. Number one. Okay, number two, what that means is the routine belongs to the class, the enclosing class, not to any specific objects. Okay, let me just put more context over here. For example, let's say we declare this R in the context of A, for example, right? And then N, okay? So class A is really the context where R is declared. So if we say class over here, all you need to do in order to call R would be you can simply say A in curly brackets dot R, and then whatever parameters you have, right? Because hypothetically, if you don't have this keyword, for example, if you scratch this keyword out, right? If you don't have the class, in that case, you will have to say creates, for example, creates maybe A, maybe some objects. You declare the object of type A dot maybe make, and then after that, you're gonna say objects dot R. So the difference between the orange and the blue is in the case of the orange, you can see the R kind of belongs to some objects that you have to create as a context objects. On the other hand, in the case of the blue, so the R over here has the post-condition class, meaning that you can simply use the class to get access to R. Class versus expanded. I would say these are completely two different keywords, so you shouldn't get confused about them. So when you say class, it's just about, you can call the routine in this way, right? So that's about the class keyword. However, when you say expanded, you're simply saying, okay, if I put expanded over here in front of the class, well, actually, let's just go back to, we talk about composition, right? When you say a class is expanded, so that means you don't have to explicitly initialize all the attributes in this particular class. That's what an expanded class is. So what's the difference between, how do you compare class versus expanded? They are completely independent construct. They don't have anything to do with each other. So Robbie, is that okay? Good. All right.
Okay.
Good. Okay, good. Okay, Botal, let's see this. So Botal's question is really about how the singleton pattern is actually implemented in the ETF, right? So let's say over here you have your ETF model. So ETF commands. So under which, let's say you got different commands over here. Let me say just two. Let me just put two of them. Let's say play. Let's say move. So this is basically our abstract commands cluster. Okay, so this is one cluster over here on the one side. And something you have to know is we actually declare something called model over here. Okay, you can think about in the ETF class ETF command, we actually declare model to be of type ETF model. First of all, that's simply an attribute that's going to be inherited to all the descending classes over here, right? And then the way we draw this is there's a client-supplier relation from here to the ETF model. Okay, let's just draw that over here. Okay, that's good. And then this one here would just be model. Okay, and then let me just, so this will be just another cluster. Let me just maybe use a different color. Slightly different. Okay, think about this is just another cluster over here, which is the model cluster, right? That's the main cluster you have to put your developments in. And this one here, let's say ETF model. Okay, so now we want to make sure, basically, every time when you try to call a command, right, in the acceptance test, for example, in your acceptance test, you might play your game. Something like you may want to say after the play, you want to say move. Whenever this event call, if on your acceptance test, you're going to create the relevant ETF command objects. So to be more precise over here, I forgot, this should be ETF play, and this should be ETF move. So this one here is going to invoke the constructor for the ETF play. So there's going to be an ETF play. objects that's going to be created, and also whenever you invoke the move in your acceptance test, it's also going to create an object of type ETF move objects, right? That's a little bit like a runtime detail. So now we want to make sure this particular ETF play objects and also this particular ETF move objects, both of them are really referring to the same instance of the ETF model. Or thinking a little bit more detail. I want to make sure whatever change I make from this particular ETF play will be making on the same ETF model objects as whatever change I try to make from this ETF move objects, but it should be making the same. So now the only way we can make this happen is by using the singleton pattern. So the way to do it is if you think about the constructor, right? So the constructor from the ETF command, which is inherited to all the ETF command classes. So if you look at the make over there, so we simply got some local over here. So we have access. And that one is ETF model access, right? And then do and also end. And the only line we put, as we learned from the singleton lecture, you will simply say the model over here. Let me use different color. So the model over here is simply assigned to the access dot m. So there's a missing class I haven't put yet. So you can think about this is another ETF model access class over here, and that one there also got a client supplier, right? Okay, so this one here is actually going to be m. That's why we can simply call the m over here, right? And then because we're also declaring the ETF model access over here, so that means we need to make sure we also have a client supplier pointing to here, right? So this will be another one over here. Let me just use this. Okay, and then if you use the draw.io to really make sure that's expanded, you will put a diamond shape over here, right? So this will be the axis. So this makes sure every time when you try to create this particular ETF play objects, you're going to call this particular constructor. And that one there is going to get the model from access.m, which and the m is, as we learned before from the singleton pattern, is actually declared to be a once routine. So it's going to return to you the same object reference every time. And then when you try to create this ETF move objects, it's also going to call the same block of code. But now this will be already not the first call to the M anymore. It's on the subsequent call. So that one is also going to return to you the same ETF model objects. Okay. So Botal, you said, does it make sense to you? Does it answer your question about the singleton? Okay, I presume you're okay. The key point, yeah. The key point, yeah, is really this class here, yes. I would suggest if you still have confusion about this, you may want to review the last part for week 5 for the singleton pattern. And then if you go to the Q&A session for lab 3, at the end of that particular Q&A session, I also try to visualize how everything worked together using the singleton pattern. So you may want to review these 2 parts. All right. So do you need any further explanation on this? Okay, good. All right. Yeah, actually, understanding about the singleton pattern that we're only changing one single instance for the model. Of course, for your projects, you shouldn't keep the name ETF model. You should really have another name. All right. Yeah, another point about if you in response to a collapse question, should you actually use the state pattern in a faithful way, using the state diagram over here? I would say whether not this diagram here, this diagram. Let me just go there. let's say if you believe the state design pattern will be useful for your project, for example, or for whatever development you're doing, okay? Should you actually follow this diagram faithfully? I would say you should if you think that's sufficient. However, if you believe there might be some specific details that will make this pattern over here not so applicable, but maybe with some small modification that will make it work, in that case, you should really do the modification, right? Caleb, does that answer your question? Well, I would say you were asking, does the state diagram has nothing to do with the phase 2? I'm not sure if they're relevant though. So state design pattern is actually for you to implement your software, right? So you're implementing the same software for phase 1 and phase 2. It is just that for phase 1, we are only testing your software using the 15 starter tests. But for phase number 2, you're still being tested the same software, right? In that case, we'll just give you some additional test cases to cover whatever that's missing from phase 1. So you don't necessarily have to implement the state design pattern in phase number 1. Maybe you just make something to work in phase number 1. But in phase number 2, after reflecting on your own design, you find that maybe I should really refactor my code to really adopt the state design pattern. In that case, you can do it in phase 2, right? Very good. Okay, any more questions? Yeah, I hope I haven't missed anything from the chat. I hope. Are we required to change the name of the ETF model? Well, I would say you wouldn't get any marks deducted if you actually got ETF model here. But, again, if you can make your design better, why not, right? Think about every class you put into the model cluster should really reflect the application you're building. So does ETF model really make sense under the concept of Space Defender 2? I don't think so. So why would you put a irrelevant class name in your design, right? So I would say, I think you should rename the class. All right. No problem. Good. Okay, I will pause for 1 more minute in case if there's any more questions you want to ask. Okay. Yeah, quite a good number of things we spoke about today. So yeah, if they help you, I hope. All right. I still have my office hours starting at 4 p.m. as usual. So if you, let me mention something here quickly. So about your lab number 3, I just made an announcement earlier this morning there. And then, so this is the partial solution I talked about for lab number 3. So this is basically just another ETF project with most of the source code over there already, right? So this is rather than about the Starfighter or the Space Defender game. So this one here is about a chess game. So you can think about conceptually speaking, they're really the same design problem over there, just slightly different details. That one there also use a 2-dimensional array, also use a grid. And also that one there also requires undo redo to be implemented. So I would say maybe take a look at the implementation there, the code. You're free to really make use of any of the code over there if you find them useful. Okay, but I think that this partial solution here is mainly for you to see how you can implement undo redo in a different design problem. So hopefully that will help you. Right? But of course, for your projects, you are not required to do any undo redo. But so this is only for you to think a little bit more about your lab 3, more like a feedback. But for your lab number 3, if you have some question about why your particular design wouldn't work, or why your particular implementation wouldn't work, you can either drop by the office hour I hold, or you can go to the TA's schedule hours, either way. Yeah, so about the project Q&A, I'm going to hold it early next week. I'm going to do that because I think given the substantial scale for the project, I think it would be more effective if I let you work on that maybe for a week or two before I speak about it. I think it will be better. But otherwise, if I simply hold a Q&A, but you have no idea about it, it's not going to be very useful for you. Yeah, so next week, yes. I'll send you guys an announcement about which day. But in the Q&A session for the project, I think I'll mainly talk about basically just maybe run the game together with you, and then maybe explain some details that you should really make sure you don't overlook from the 15 acceptance tests that we gave to you. It's mainly the purpose of that. I may not simply just read together with you about the PDF documents or messages.txt. That might not be a very good use of your time. So I'm just gonna maybe do some running of the Oracle together with you. That's what I would do. Okay. But I would say if you got any confusion about how the game works, please post on the course forum. Both me and Kevin, we have been moderating the course forum very actively. So you can definitely make use of the course forum. I think that'll be the best venue for you to ask questions regarding the game. Okay. Of course, if you got more specific question about your design, drop by my office hour, or you can simply discuss with the TA, depending on your schedule. Okay, you can make use of these resources given to you. All right, so final call. Do you have any more questions about week number 8's lecture before you take the quiz? All right, it seems like everybody seems to be okay. All right, yeah. Again, thank you for coming to the Q&A. Best of luck to your quiz, and then please make sure you spend enough time on the project so you will be able to ask us questions. Okay. Any difficulty you run into, please get in touch with me earlier rather than later. And then, I'll see you later. So I will end the meeting now. All right, guys, take care.